Hello and welcome back to Coder Key. In this video, we're going to discuss prime factors. We're going to calculate the prime factor of a given number. We are in the seventh chapter of our mathematics series in data structures and algorithm using Python. So let's get into it. Okay. So now, when we talk about prime factors, very basic problem, right? So suppose we have to calculate prime factor of 100. What we do is we divide it by the lowest prime number, that is 2. Okay, we write 2, we divide it by 2, and we see that we got 50. Now again we're going to do the same thing, that we're going to divide it by 2 because it is divisible by 2, right? So we're going to divide it by 2 and we are going to get 25, right? Now we're going to see whether it is divisible by 2. No, that means this number is odd. Now we will not be able to divide it by 2. So we'll check for 3. Is it divisible by 3? No. Now check for 5. Yes, it is divisible by 5. And now what? It is divisible by 5. We have divided by 5. We have written 5. So if we give an output 100, so what output, sorry, we give an input 100, what output we're going to get? We're going to get 2255. We divide, we write. We divide and we write the number by which we have divided. We divide and we have divided, written the number that we have divided, right? So if you see a pattern in this case, okay, in here, if you see a pattern, what we did is we started from a lowest prime number, okay, that is 2, okay, and then we have divided it by 2 until and unless we get odd over here, right? So if the number is odd, or if the factor that we got is odd, then we will not be able to further divide it by 2, right? So this number will always be odd after multiple times dividing it by 2. Okay, then after that we are going to check for rest prime numbers like 5, 3, 7, right? So okay, so we got these 4 as our prime numbers. Okay, so now there is an algorithm that is called as Poland's row algorithm. This is an algorithm for calculating the prime factors of large composite number. If you want to get into the topic, you can check this algorithm out. I can link uh, you know the algorithm in description. Okay, now before moving forward, or before moving towards the algorithm, I like to tell you few properties that you need to understand of basic prime numbers or prime factors. What I can say is the set of these prime factors is going to be unique, right? For every number we're going to have different prime factors. I cannot say set, but the list of the prime factors which you're going to get over here is unique for all numbers, right? And you all know that one is neither prime nor composite. Okay, so that, because we need to understand that we cannot divide it further, right? Because what we're going to get, we're going to get 1 and 5 as what, but 1 is not prime number, right? So so this is the thing that you need to understand, that it is going to be unique, and it is one is neither prime nor composite. So what I decided to do in this uh, for this particular video is that, let us first of all understand the algorithm, let us see the code how it works, and then we will see or run the code. Okay, we will see the code, we will understand the algorithm, we will see what properties is being used in this, and then we will end the video. So this is an algorithm that I came through, or I have seen. Like, so what we do is basic. It is written over here also, that we first of all we divide the number given number n by 2. Okay, by 2 until we get n the number n as odd. Okay, so while n is divisible by 2, we're going to print n, and we're going to divide it by 2. Okay, we're going to print 2. Yes, the 2 is a prime number, 2 is the one of the factor, and then we're going to divide it by 2, right? So now the another step is, now after this step what we're going to get is that the number is going to be odd from now on, right? So the now n will be odd, and now we're going to start a loop from I equals to 3, because of course we have checked by 2 till root n. Now why here root n? Here comes the property of composite number that is important for you to understand. Okay, so what exactly property is that every composite number, okay, every composite number has at least one prime factor which is less than or equal to square root of itself. This is the property, and this you need to remember when you solve this kind of problems. Okay, so this particular problem is going to give you a little bit insight about, yes, about mathematics, okay, of prime numbers and composite numbers. So here, what I told you, in first step we're going to get what, we're going to get all the, even numbers, and we're going to divide all the even numbers by 2. In second step we're going to get odd, and for, further dividing it, or further finding the factors, what we're going to do, we're going to start a loop from 3 to root n, y root n, which we are going to see over here. So let us consider what the statement is given is like, if suppose we have a number n and it has two prime factors p and q. Okay, very simple. We have n and we have two prime factors n and q, and according to, the according to this property, it is saying that either of two, p or q, should be less than or equals to root n according to this property. Now let us prove this, and we're going to use, contradiction method for proving this. What we said, what we are given is that n is having two factors p and q, or either of the two is going to have root n. uh, Either of the two will have factors which is less than root n. So what, according to this, what I can say is p times q is n, right? P times q is n. So now, uh, let us contradict this. Okay, this is to prove, and now we're going to contradict is like p is, greater than root n. It is not less than but greater than, and q is also greater than root n. It's not less than but greater than. Now let us multiply these two. So we're going to get p q greater than n, correct? But these contradict to our, given statement that, or are let that p times q is n, but here it is saying that p times q is less than n. So this is wrong, right? This should not be the thing, because this is the thing that we know and this is true. So we can say that it is not greater than, but p times q is less than or equals to, we can say, root n. Was that clear? So this is the property. I have shown you the proof, and I have given you the reason why we are doing it till root n. Okay. So the composite number, the factors of prime factors of any composite number is going to be between what? It's going to be between 0 to root n, let us say. But we have checked for 2, not 0. Sorry, 2 to root n, right? We have checked for 2. Now we're going to check from 3. So 3 to root n. So now we are going to divide I with n, okay, where I is between 3 to root n, and we're going to print that number if it is divisible, and we're going to further divide it by I. So, I have written small pieces of code over here so that, we can understand it from here only. So step one is doing what? Step one is going to give us, uh, deal with even numbers, right? Even numbers. So we're going to go right, root n is equals to 0, sorry, n modulo 2 is equals to 0, and print 2 if it is, and further divided by 2 again, okay, until it is divisible. Okay, then in step 2 we run a for loop, right? We run a for loop from 3 to square root of n. So you need to remember to import square root, okay, from math module. And of course we're going to do plus 1, but what is the catch? That we need to increment it by 2, because we know we are not going to get even numbers now. We need to divide it by, odd numbers only. Okay, so the step 2 is going to deal with what numbers? It's going to deal with, let me choose a color. It's going to deal with odd composite number. Odd composite number, correct? So the step 2 is going to deal with odd composite numbers, and if I fails to divide n, then increment 2, okay, and continue. Okay, moving forward. Now we're going to have the third step. Now if n is prime, we have, studied, we have analyzed even numbers, we have analyzed odd composite numbers. Now the thing that is left type of number is prime numbers. So if a prime number is greater than 2, then n will not become 1, okay, by the above two steps. So we're going to print n if it is greater than 2. Okay, if n is left, if we get something as n which is not equals to 1, okay, from above two steps. So we're just going to print uh, n if it is greater than 2. Yes, it is. Was that, was that understandable? Have I made myself clear? So this was an algorithm, very simple. Okay, let us run it. Okay, uh, by prime, sorry, sorry, prime factors dot by. Okay, so we had 335, and the prime factor of those are of it is, 5 and 67. Let us try for 100, so that you will be sure with our answer should get 2255, right? It is. Yes, you can make it better, output looking better, but this is the gist, right? So what we have done over same thing, we have imported the maths model. That is important, right? So we have the step one, that is for checking prime numbers. Then step two is for checking what, odd composite numbers. Step three is for checking the prime numbers which comes greater than 2. Okay, and then we print those numbers, right? Was that simple to understand? Okay, so in next video, what we're going to have is, we're going to have uh, a sieve of Aristoteles. We're going to see its very interesting problem. Okay, so this is it for this video. I hope you like it. Make sure to subscribe so that you never miss any update regarding the video, and see you in next video. Thank you. If you have any doubt, you can comment in the comment section.